it's on. Thank you, Harmeet. And thank you to everybody for coming along this evening. And take a bit of your time. We've got a really exciting presentation tonight. And we're going to follow our usual program for this evening, which is we're going to introduce our presenter and our main talk. And then after the talk, we're going to talk about Community Marketplace. So Community Marketplace is an opportunity for anybody to introduce themselves and talk about an open source project that they might be interested in or working on, something they might want help with or interested in hearing a talk on, because we're really interested about that. If there are specific topics that people want to look at and explore together as a community, then we'd love to do that. And also if people are looking for work opportunities, then the Community Marketplace is an opportunity to put yourself forward and explain what sort of work you're looking for and what sort of skills and experience you might have, in case there's somebody on the channel that might know about an opportunity or have an opportunity, that they can also share those opportunities with the community in case somebody is interested in them. So without further ado, we're going to kick off with a talk from Nishant. Nishant, I believe, is a new father who's been juggling family life and doing extraordinary things, solving some really visible and really exciting projects for customers. And he's got a wealth of experience now about Apache Airflow. And I think he's going to take us on a bit of a journey this evening to learn a bit about Apache Airflow. And I think he might even have a demo for us, which would be great to see it in action. So without further ado, I'll hand this over to Nishant.
Thank you, Tim. Thank you so much. I'll just share my screen. Give me a moment. Right. Is that visible?
Perfect. Thank you.
Excellent. Thank you everyone for joining this session today. Really appreciate it. So today we're just going to go through Apache Airflow, look at what it is, what it does, where you can use it, and my personal experience with it in the last couple of years working with Airflow. Now, across the last couple of years of working with Airflow, of course, I've used it in different facets and trying to solve different problems. Essentially, it's the same problem, which is the data orchestration, but in different ways. So we're going to go through some sort of high-level overview of those use cases and how you might end up solving them. You can, of course, take some inspiration from the work that I've done with those use cases before. And yeah, we'll look into that. In terms of the agenda, so we're not going to do a slideshow by that. So we're just going to spend a very brief period on the slides. I've just got a couple of slides to go through, the fundamentals around Airflow, what it is and what it does, certain key concepts that will ramp us up into those live demos. And then we're going to go through the live demo themselves. So we're going to touch on 3 distinct use cases, how to create a DAG. Now, DAG as a concept is something that I'll touch on in a bit, but essentially it's pipelines that we'll end up creating within Airflow. So we're going to do some basic DAG creations. I'll be live coding, and we'll look at how easy it is to actually roll out a DAG in Airflow. Then we're going to go through use case 2, where we're going to look into the real power of Airflow as compared to your old school orchestrators like Control-M. So essentially, how would you create dynamic DAGs? So again, I'll talk about a bit more when we get there. And then the third one is a bit out of the left field, which is the event-driven DAGs. Again, I'll explain the context and walk through that use case as well. In the end, we'll wrap it up with the lessons that I've learned over the past couple of years in terms of the gotchas of Airflow, what you should be cognizant of when you're working with Airflow, and so on and so forth. and we'll do a bit of a Q&A at the end as well. So,
same, Nishant, with the
yeah.
Q&A, would you like people to write them into the chat window, or just hold on to them to the end, or?
Oh, yeah, sure. That would be fine as well. Or I've also got this link so that I can see the questions in real time. If I can answer them while I'm demonstrating as well, that's fine as well. So either
Fantastic.
ways works. So I
That's
think
great.
it'll be more convenient with the Zoom call, I suppose, isn't it then? Yep. So yeah, yeah, so that's okay. I mean, the questions can arrive there, and we can take them at the end or as we move along. Cool. So now Airflow, essentially, it's a workflow management platform. So it is in the data engineering world, we essentially use it to orchestrate our ETL pipelines. The main thing that sets it apart from other orchestration tools, like I was saying before, like your old school orchestration tools like Control-M, which was more click-opsy in nature, where you drag and drop and you'll manually configure each of the tasks within your pipelines. The difference here is you'll be authoring them programmatically, and you'll be using Python for it. So essentially, any pipelines that you want to create is essentially hand-coded. And now, since we enter into the programming paradigm, of course, you can use wonderful things like your for loops and your while loops to essentially create DAGs dynamically, right? And again, we'll get into those things later in this session. Now, on top of that, of course, it comes with a very rich user interface, which allows you to monitor and visualize your pipelines in different kind of views. Again, we'll look into that in a bit. You can monitor the progress of your pipelines in real time as it is progressing through the tasks as well. And then, of course, you can dig in deeper and troubleshoot any issues that you might face while running these pipelines. So you can click on the task, look at the logs, and debug it that way. Now, as a platform itself, now theoretically speaking, it is infinitely scalable because you can have an arbitrary number of worker nodes. So it works in a master-slave sort of a configuration. You've got a master node, which we call as a scheduler, which is responsible for scheduling your pipelines and the tasks contained within those pipelines. And the worker nodes are the ones that are actually executing those tasks for you. So it is, in terms of the platform framework itself, it is very nicely scalable. Since all the DAGs are sort of programmatically written, and considering the fact that Airflow is open source as well, so of course you can create your own plugins and extensions on top of it, which makes it very desirable for organizations so that they can make it their own without having to pay hefty licensing costs and so on and so forth. So moving on. So in terms of the key concepts that we should be wary of before we get into those live demos is when we say pipelines in our jobs and Control-M or tools like this, Airflow, in Airflow context, we call it DAGs. So DAGs is nothing but a pipeline, and DAGs essentially stands for directed acyclic graph. So directed acyclic graph for the uninitiated is nothing but a unidirectional workflow, and it doesn't have any cycles in it. That's why it's called acyclic. So one of the examples that we can see over here, this is a representation of a typical DAG, what it would look like in the Airflow interface. And it is, as you can see, it can sort of merge back in, but it is always unidirectional. It will never have cycles in it. Now, the DAG's edges are essentially the tasks within the pipeline that will be running, and tasks is essentially a concept, but the implementation details of the tasks is operators. Now, again, in Airflow language, operators are actually executing the work within a task. Again, we looked at different operators in the live demo, but out of the box, Airflow comes with 3 flavors of operators. So one is the sensor operator, then you've got the action operator, and then you've got the transfer operator. Now, sensor operators, as the name suggests, is essentially used for sensing on a particular event to take place, right? Some examples of this could be you're waiting for a file to arrive in a directory, in a storage volume, or an SFTP endpoint, or an S3 bucket if you're using AWS, or a blob storage if you're working with Azure, and so on and so forth. So once that condition is true, let's say a file is created, then that particular task, the sensor task, will be ticked as a success, and then you can kick off any other downstream tasks to do whatever you want to do with it. Could be transformation-based tasks, and could be anything. Yeah. Then the second category of operator are action operators. So essentially, action operators, again, as the name suggests, you're essentially doing some action in it. The 3 most common operators that I've worked personally with are the ones that are listed over here. So you've got bash operator, which is essentially used for executing bash scripts. SSH operator, essentially, it is used for creating a remote session with a server and then executing a remote script over there. And then you've got Python operators, wherein you can just execute custom Python code. One of the other ones that I've used before is an HTTP operator as well, wherein, let's say you want to call an API, you want to do a POST request or a GET request. So those are the most commonly used ones. So we look at least 1 or 2 of these action operators when we get into that live coding session. Now, the last one, the last flavor of operators, the transfer operators. So these operators are essentially used for getting your data from point A to point B. So again, got some examples up on the slide. So if you want to get your data from a database to an S3 bucket, or you want to go from database to a database, or you want to go from S3 to a Redshift, or you want to store it in a data warehouse or a data lake. So, so that's where transfer operators come into play. So the next part we're going to dive right into it, even though I've just covered a very high level concept that will sort of get us started. But we'll touch on more key concepts as we work through these examples and look at these tags in action. All right. So the first case that we're going to look at is how would you go about creating a simple DAG, right? So we're not going to do anything fancy over here. We're just going to create a bunch of tasks. How do you create these tasks? How do you create dependencies between these tasks, and so on and so on. And we'll try to execute these tags as well if the DevOps gods are good enough. All right, so are you still able to see my screen? Okay, perfect. So now, just before I go into the coding part of it as well, so firstly, let's get ourselves acquainted with the Airflow interface or the UI. So essentially, when you log into the Airflow interface, this is the homepage that you'll be looking at. So on the homepage, what you'll see is the list of DAGs or the pipelines that have been created so far. And each of these tags might correspond to, explicitly written a Python program which creates a DAG object for you, or they could be dynamically generated as well. Again, we'll look at those cases in a bit. And even in the dashboard, of course, you'll see the high-level information in terms of the DAG name, who is the owner of the DAG. So if you have multiple teams and people collaborating on the same Airflow instance. So you can sort of filter the DAGs by owners and such. And then it gives the next column over here gives you the status of the recent runs that have happened for the DAGs. So going from left to right, how many DAG runs are queued. Again, we'll go through these statuses as well. So essentially, because not all DAG runs can be simultaneously executed, because of course you have limited number of worker node capacity, they might be in a queued state. How many recent DAG runs have been successful? How many are currently running? For example, our queue reader DAG is currently running at the moment. And how many of them have actually failed, right? Now, when you click on any of these tags, so let's maybe click on this. So you're greeted with a graph view of the DAG. So essentially, this is the graph representation of the DAG itself. So of course, there are a lot of tasks over here, but I won't get into that just as yet. We'll ease into it. What essentially I wanted to touch on is the different views that Airflow provides you to visualize your DAGs, right? So you've got a graph view that gives you the latest run of the DAG and how the DAG has been actually structured. Then you've got a tree view. This is a bit more difficult to follow in the sense that it sort of gives you a view of the last how many ever runs that you've selected from this top left hand side drop-down box. But it gives you a cumulative view of all the recent runs, a high-level view of what tasks have failed versus what have been successful. So, for example, all the dark greens mean that they have been successful, and all the red ones mean that they have actually failed. And all the orange one actually mean that they were dependent on an upstream task that have failed as well. Now, one of the recent features that Airflow introduced, which wasn't available up till I think a few months ago, which is the calendar view, which comes in pretty handy from an operational point of view as well. So you can look at a few months out in terms of the number of runs that have happened, how many runs have failed. So it's essentially a visualization of the trends that your DAG is going through, right? So these are the three main views that personally I've used while using Airflow. There are other views as well. So you've got a Gantt chart view, which will give you a breakdown of the time taken for each of the tasks. Then there is the task duration view, which is essentially a graph representation of the amount of time that the individual tasks have taken, and so on and so forth. But in my experience, more often than not, most of the time that you'll be spending is within the graph view if you're trying to trigger a DAG from a point of failure and so on and so forth, right? Now I'll just go back to the home page. Now, one more thing that you'll notice here, and this will transition into our coding, the live demo part of the session, is this DAG import error. So for example, if you're coding on the DAGs and for whatever reason we have syntactical errors within your DAG, right off the bat, just on the home page at the top of the screen, you'll see these DAG import errors, which will complain about that your DAG is broken. It will give you the exact line where things are not looking good. For example, over here, I've got a problem in this particular Python file. So use case 0, that's what we're going to work on in a bit. And it is saying that the key has to be made alphanumeric dashes and dots, and that was deliberately done so that we can sort of get that working, right? So without further ado, let's have a look at the code. So essentially, this is the file that we're going to work with for a bit.
Hey, Nishant, sorry, would you be able to increase the font size?
Oh, yeah, sure. Sorry. I
Yeah.
didn't realize. Is that good enough?
Yeah, good. Thanks.
Excellent. Okay, so I've got some boilerplate stuff in this file at the moment. So what we're going to do over here is just for the ease of it, let me just shift our slide over here. So what we're going to do is we're going to create this DAG, all right, from scratch. Now, the only boilerplate stuff that I've got here is I've imported a bunch of Airflow libraries that I'm going to use. So essentially what I've imported is something called a dummy operator. Now, dummy operator is very different to all the other operators that we were talking about earlier. The main task of this is generally used for testing purposes or segregating your DAGs and making it a bit more prettier. So let's say you have one task which is forking into 15 different tasks, which again is going through complex structures and dependencies, and that might be a phase in your ETL process. So if you want to sort of make it cleaner in your DAG view, you would be using something like a dummy operator. For here, for this particular use case, we're just going to stick with dummy operators to just sort of make it simple to follow. And then you can take solace in the fact that you can actually replace it with actual operators that would do actual work, right? Similarly, I've got a Python operator, a bash operator. If the time allows for it, we will delve into those as well. So I'm just going to skip through this commented part. I'll touch on what that actually is. Now, the first, and yeah, ignore this part as well for now. The first thing that we're going to focus on is creating a DAG object. So what happens is the Airflow setup, essentially the master node that I was talking about earlier, which is called a scheduler node within Airflow. It is based on the configurations that you've given it. It is actually traversing through a particular directory location where you'll be placing all your DAG files, all right? And when it scans through all these Python files, it is looking for a global DAG object, DAG objects at a global scope. And as and when it discovers a global DAG object, it essentially populates it in the UI as we were seeing earlier. So the first order of business is that we need to create a DAG object. Then we'll start adding tasks to the DAG and we'll see what happens on the UI, right? So I've created a DAG object over here. The first argument that you pass for the DAG object is essentially the DAG name. So let's just call it Data Engineering Melbourne, Meetup, DAG 0, right? Now, the second thing is, so essentially when you have a pipeline, of course, you'd want to schedule it to run at a particular cadence, right? So in let's say you have to run a batch, an ETL batch daily. So you can either give a cron expression like this, or you can also give a shorthand for those cron expressions like daily, or you want to do it weekly or monthly, and so on and so forth, right? So that's the schedule interval. Now, the last part that I've passed here is default arguments. Now, more often than not, at least in my experience, what I've noticed is there are certain arguments that are common that I want to apply commonly across all my tasks that follow it. So when you're creating the DAG object like so, you can just pass these default arguments within the DAG object and they will be applied to all the tasks that you consequently create within this file, right? Now, that's why I have this commented code part, which gives you a view of the amount of default arguments that it can accept. So you can do things like, establish an SLA for your DAG, do failure callbacks, do success callbacks. You can do emails as well. Let's say when a pipeline fails, you want an automatic email to be sent to your operations team or the support team. So you can do things like this as well, right? But for the purpose of this demo, we're just going to keep it simple. The only thing that I'm passing is a sort of a DAG level argument, like the owner and the start date for the DAG, right? Now, in order to create the tasks, right? Essentially, because Airflow is already providing all of these libraries for us, we don't have to sort of code anything from scratch. We can just use the Airflow API to create our tasks, so and then link them together to get to the stage that I was talking about earlier. So in this instance, I need about 6 tasks that do something, and then we'll establish the relationship in later, right? So I'll just create one task over here. So I'll just call it run me 0. Yeah. And I mean, these are just basic Python variables, so you can name it whatever you want. You can name it bananas and apples, whatever have you. So I'm just sort of trying to keep it consistent so that we can follow along. Now, what I'm trying to create, so like I said before, we're going to use dummy operators, right? So essentially, I'm using the dummy operator object that is available in the Airflow operators library. And invariably, every task that we create, it will always accept 2 variables by default. One is which DAG object do you want to link this task to? So in this case, I've got a DAG object by the variable name DAG. So I've just passed that along, and the task ID for that particular task. Now, whatever you put in over here is what you see in the Airflow interface, right? So I want to keep it consistent with what we saw in that slide. So it's run me 0. Yep. So I'll just name it that. Now, this is our first task. Now, if we were just to save this, we don't do anything, we just save this. Let's see what happens, right? So I've just saved this. We'll go back to the Airflow interface with a bit of a refresh. Firstly, that error is gone because we resolved that error, right? And secondly, we've got a new DAG over here by the name dem meetup DAG 0 that we just created. And if I click on it, I've got one task, which is a dummy operator, right? So now we can sort of accelerate through the next few things. So I'm just going to quickly create those 6 tasks that we are after. So there was run me 0, there's run me 2. So one gotcha over here is you can never have duplicate task IDs. If you just save it in this state, it'll again show that broken DAG error saying that you cannot have duplicate task ID has been discovered. So please correct that error. Now, sorry, just going over here. So run after loop, also run this and run this last. So run after loop, also run this and run this last. So I'll just keep it consistent between the variable name and the task ID. All right. Now, if we go back, so I've just saved the file. If we go back to our graph view over here, again, give it a quick refresh. So we've got all the tasks that we were after in the Airflow GUI. The next step is to actually create dependencies between these tasks, right? Now, this is where it sort of goes beyond the realm of Python. So the way you would, and it's one of the ways how you would establish dependencies, and this is the easiest way that you can do. So let's say what I want to do is, just for example's sake, if we look at one of the cases over here, we see that also run this is an upstream task for run this last, right? If I just want to establish this dependency, all I got to do is use this variable, also run this, use a bit shift operator pointing towards my subsequent task, and just do this, right? And if I just save this, go back to my graph view, do a quick refresh. So I've got that relationship over here, right? Now let's make, now let's do the rest of it. So over here, what we are seeing is run me 0, 1, and 2, all point to run off the loop, all right? Now you can do the same thing as over here. So, I mean, you can do exactly this thing that we were doing with also run this and run this last. So, and this will work, right? And you can also sort of copy this across like this, and this will work too, right? So if I just do a save, so the Airflow scheduler, when it is sort of interpreting all of these dependency, it is smart enough to figure out, even with these sort of repetitions, that's how you want to actually structure it. So it will give you a nice little view that you're actually after, so that it doesn't have any problems with repeating those variables in different sort of relationships. So if you see here, we've got also run this that we created earlier, and then we've got run me 0 and 1 to pointing to run off the loop, right? But a more elegant way of doing this is to essentially, if you have multiple tasks that are sort of joining into one task, you can essentially enclose all your variables into a list. So I can just have this over here and then have this as well. So this is another way of and more elegant way of establishing that relationship where you have multiple tasks that are upstream for another task downstream. If I just give it a quick refresh, and we've got what we were after with this particular flow. Now to close this off, so we've got run after loop and also run this pointing to run this last. So, well, we can do the same thing as we were doing earlier. So we can just do also run this and run after loop to point to run this last, right? And we can just get rid of this line now. Now, once I save this, sorry, and go back to my Airflow graph view, and I get what I was after, right? Now, this is like one of the simplest sort of DAGs that you can actually create. Things can get complex pretty easily, depending on the kind of cases that you're trying to create these pipelines for. Now, the main point of using Airflow is essentially, like I was saying before, using the programming paradigm to its advantage. Now, before I do that, so for example, if I look at these three tasks, right, they are sort of following a pattern. If we can just assume that these tasks are essentially addressing the same pattern, they are sort of executing the same tasks, but with different parameters. Let's say it is doing extractions, for example, right? So you're extracting table 1, table 2, and table 3, right? So what you can do over here is, So for example, I can do something like this. I'll declare a table array. I'll say there's a table A, there's table B, and table C, right? Now what I can do is I can just iterate over these tables and generate these tasks on the fly and establish those relationships that I was talking about down here, right? So what I can do is I can simply say table extract is equal to, I'll just cut this over here, and let's make this a bit more intuitive. So extract A, oh, sorry, table, right? So now we don't need any of these. However, what we do need is to establish the relationship between within this for loop. So what I can say is table extract is going into run after loop. And of course, I'll have to declare this above that because it goes a bit out of order. And then I'll save this. Now, this is all sort of basic Python programming from here. So it's very easy to sort of generate these pipelines from now, right? So as you can see, I've just generated these tasks on the fly using a simple for loop. So it comes in very handy when you have taken a pragmatic approach in terms of designing your pipeline. You've established a pattern that your pipelines are going to follow, and then you can do something like this as well, right? Now, just to, of course, we would want to run this DAG before we move on. So what I'm going to do over here is instead of using a dummy operator, because if I run this right now, because it's not doing anything, it will just go in a flash, right? So what I'm going to do is I'm just going to use a bash operator and just get it to sleep for like 5 seconds or so, right? So we can see it going through the relevant statuses that we were talking about earlier, right? So now the bash operator, of course, expects more parameters to be passed to it. And these, the Airflow documentation is very nicely structured. And so you can get all of these references from their official documentation in terms of what parameters to pass and how to use these operators. So in this case, we just have to run a bash command, right? So the additional operator that, sorry, the additional parameter that it accepts is a bash command. So just do sleep 5 and just hit save. Just do a quick refresh. Now, before I run this, if you've noticed the color of the task has changed. Again, this is out of the box feature from Airflow, wherein you can sort of see what each of these tasks are using as operators, right? So if on the top left-hand side corner, you can see all of these tasks are color-coded. So as I can see, the light green color is my dummy operators. This grayish brownish color is my bash operator, right? So at the moment, this DAG is enabled. So the first time you create the DAG, depending on the configuration that you've got in Airflow, it will always go in paused or unpaused mode. So in this case, I've kept it in paused mode. So I'll just enable it. Again, just have it auto refresh. And oh, I've kicked off a lot of runs. But anyways, so as you can see, it is going, so all of these tasks that didn't have sleep in it, it was dark green in color. And while this was running, sorry, let me just give it a bit more sleep over here so that we can actually see transitioning from one status to the other. Okay. So while the also run this is running, it'll be in a bright green color. Now, again, you have a legend on the top right-hand side corner to see all the statuses, and you can highlight the ones that are in running. So the UI is pretty interactive and pretty intuitive if you actually play around with it. And a task can go through all of these statuses. So it could be in queued state if it is waiting for an open slot within the worker nodes. Running state, as you can already see, this is running. Just auto refresh it. Success state would be essentially it has run successfully. Failed, of course, signifies that it has failed. Up for retry. So if you use the retry functionality within these tasks, so it has the capability of doing automatic retries. For example, you might use these wherein you have you're interacting with a database, for example, right? And for whatever reason that database is down, so you might introduce an automatic retry, to try it again in 15 minutes or half an hour, if that is the kind of SLAs that they sort of maintain in terms of recovering the database. Or you can even implement exponential backoff. So all of those features come out of the box, right? So that's essentially how you create a simple DAG. Any questions that are in the chat at the moment? Sorry, I'm not able to see any.
There was a question earlier. Sinesh asked if you could elaborate a little bit on how you get Airflow installed, whether you're running it inside a Docker container or a Docker image, or how do you get started and start this UI up?
Oh, yeah, sure. So what I can do after this presentation, so at the moment, I'm running it in Docker. So if you see here, I've got a Docker compose file right here. So I'm happy to share this with the wider group, and you can just do Docker compose up and you'll have a Airflow up and running on your local systems. But in a production environment, of course, it depends from use case to use case and companies to companies, because there have been instances, for example, I've used Airflow hosted in ECS. So each of the components of Airflow was containerized, and we were using Elastic Container Service within AWS. And in Azure, I've used it in Kubernetes. So you can also use Kubernetes for hosting your Airflow stack. Something that I'm going to touch on later in terms of lessons learned is because there are two aspects of it, right? So either there might be a DevOps team who is sort of maintaining the infrastructure, and then there's a data engineer aspect of it where you're just sort of authoring these Airflow DAGs. But even as a data engineer who is authoring these Airflow DAGs, what comes in really handy is actually understanding how all of these components interact with one another within Airflow, because that helps you in actually figuring out it helps in troubleshooting, really. If you see all of a sudden a task has failed, but you cannot see the logs, right? So there's a specific reason why you won't be able to see it. All of a sudden you see that there's a sick term error. Why did that happen? Because I didn't do anything as a developer to do it. So that comes in very handy to understand those components. I'll maybe get into that towards the rear end of the session.
Sure.
Sorry,
we've just got a couple of other questions.
Yep.
Someone asked, how do we pass values between nodes?
Excellent. I'm going to cover that in the third use case.
Awesome. Yeah. There's a bunch of other questions. Everybody's got lots of questions. Someone asked, is this Airflow 2 that you're looking at? Is it version? Do you know what version it is?
Yes, it is Airflow 2.1.4, if I'm not mistaken.
Right.
Yeah, 2.1.4. Yeah.
Sure. And how do you feel about running it on OpenStack or OpenStack Kubernetes?
So personally, I haven't had any experience in doing that. Sorry, I cannot
Sure.
speak to that actually. Sorry about that.
That's okay. That's fine. And what are your thoughts on AWS managed Apache Airflow? I think AWS do have an Airflow offering.
Yes, yes, they do. They have MWAA. In the early days, so when I started using Airflow a couple of years ago, the first place where I started using Airflow was within AWS, but we weren't using MWA because that wasn't a thing back then. But after it came out, again, I've personally not worked with it, but I've heard issues around its stability from my colleagues. They haven't been entirely happy with the way it works. So at the moment, my view on this is it is not stable enough if you are going to use it for business critical sort of use cases. So might give it a bit of a time to sort of come to parity with
Sure.
how you would actually manage it yourself.
And Sinesh has asked again, do you spend your time as a data engineer creating the operators or the DAGs?
It's a mixed bag actually. So the operators themselves, see, more often than not, the operators that Airflow actually comes out of the box with are more than sufficient to sort of solve all the use cases that you're after. In addition to that, there are other community contributed operators as well that you can use. But there are use cases wherein you want to standardize a particular, for example, let's say there is a process that takes around combination of 5 different operators to complete, right? And it's not a once-off job. And this is a pattern that you're using again and again across, say, 10, 15, 20 or pipelines. Then it will behoove you to actually sort of combine the functionality of all those 5 operators into a single operator. And especially when you have sort of multiple team members of varying technical skills sort of contributing towards that project, right? So
Sure.
it sort of lowers the barrier to entry if you're joining the team fresh and you have to wrap your head around 5 operators, which can actually be done with 1. So again, it's sort of use case dependent. Yeah.
Yep. I'm just conscious of time. We've got 3 more questions, so we'll go for a rapid round of questions, and then
Yeah.
we'll let you keep going with the talk.
Yep.
Now we've got a 4th one. How do you make conditional flows? If you wanted to make that pipeline and have some conditional elements, can you do that sort of thing?
Yes, we can. So there is a kind of an operator called branch Python operator, or branch operators in general, and one of the ones that is commonly used as a branch Python operator. So, for example, if you have sort of one task sort of forking into 2, and you would want to follow like one flow and skip the other one, you can use a branch Python operator, which what it essentially does is it'll call a Python function, and you can do some logic in it to determine which path you want to take. And at the end of the Python function, you just return the task ID of the path that you want to follow. And then,
Sure.
yeah, so that is, you can certainly accomplish that.
Another question, can we define the specific worker where we want to run the task? I'm a bit vague on that one. And you might have some more context for that.
It will, so maybe I understand what this question is. So I've heard this question before, wherein, let's say you want to sort of direct workloads, like relevant workloads towards worker nodes that have limited access to other systems. In those cases is where sort of this question sort of becomes relevant, but it is easier said than done. there's no out-of-the-box configuration that Airflow comes with, wherein you can sort of segregate worker nodes. That has to be a custom solution that you'll have to implement.
Great, thanks. What is the version control mechanism for Airflow? Can you use version control for this code and these DAGs and things that you're making?
Absolutely, absolutely, absolutely. Because this is all Python code that we are seeing here, right? And that is in fact encouraged. So you essentially use, so once you get into the programming paradigm, you can sort of do version control. You can use CI/CD pipelines as well. You can run unit tests on these if you want, and then have it deployed to a storage volume where the scheduler is scanning for these Python files as well. So all of that is achievable.
I think you just made someone happy when you said you can do tests. You can test your DAGs. Another question. Someone said, can we hook DAGs together? Can you link your DAGs?
You can trigger one DAG to another. There's another concept called sub DAGs, wherein you can essentially have your common functionalities defined in another DAG and use it as a sub DAG for your parent DAG or parent DAGs, if you will. So of course, that is achievable as well using those concepts. So the keywords over there, sub DAGs. If you want to do that, look into sub DAGs. If you just want to trigger one DAG from the other DAG, which we'll be looking at in a bit anyways, then you'll be using an operator called trigger DAG run operator. Yeah.
Fantastic, thanks. I think that's all the questions we've got for now, so I'll let you get back on to your presentation. And yeah, just keeping an eye on time there.
All right, I'll motor through the rest of it. So I just wanted to establish as to how easy it is to create these tags, and then from here you can get your let your imaginations run wild. So no matter how complex your orchestration looks like, it is absolutely achievable as long as you can create these tasks, link them together. It then really doesn't become the question of what you can achieve with it, but how you would actually go about achieving it, because these can sort of become very complex very soon. So you have to sort of make sure your designs are appropriate and you're sort of trying to keep things simple so that you can actually support it when it is in production. So now moving on, just going back to the slides. So yeah, so we looked at the simple DAG creation, we looked at the simple DAG creation. We looked at how you can add tasks, how you can establish dependencies, and understanding the task statuses as well, right? Now, the second part that I wanted to touch on was DAG Generator. Now, this is one of the most common use cases that I've seen in organizations. More often than not, what happens is when you're creating these orchestration pipelines, there are patterns that you're following, right? And these patterns establish ahead of time. Now, all you have to do is you have to generate DAGs that follow these patterns repetitively, right? So what you can do is, since like I've been saying, this is just Python programming, right? So what you can do is, imagine you have a configuration file, like a YAML file or a JSON file, wherein you sort of put your orchestration details. Like this is, for example, you're doing extraction pipelines, yeah, which depend on upstream events and other upstream tasks that are happening, or certain time triggers, right? And let's say you want to extract from an Oracle database, or you want to extract from an NFS mount point, or you want to extract from these different kind of sources. So in each of those instances, the behavior of those tasks will change, right? And if you have different upstream dependencies, then that will change as well. So if you can define all of that as a configuration and you create a Python program that actually parses through that configuration and just creates this DAG object for you, then it becomes very simple for the team to just onboard new DAGs which follow a similar pattern again and again and again, right? So one of the very simple examples that we look at is looks something like this. For example, I've got 3 patterns, pattern 1, pattern 2, and pattern 3. Each of those patterns, let's say pattern 1 is about extracting, doing ETL on 5 odd tables. Pattern 2 is about doing 4 tables, and pattern 3 is about doing 4 tables again. And these could be, this could be any configuration. You can put in anything you want in this JSON construct, right? And you can parse it and do anything you want with it. Now, in this case, what I'm doing is I'm just iterating through these configurations. So that JSON construct, I'm going config by config. For each of those configurations, I'm creating a DAG object, right? And I'm sort of creating the DAG name dynamically as well, based on the configuration as well. So if I look over here, so this is name. So that's what I'm using for my DAG names. And then for each configuration, then I'm creating a couple of dummy tasks like a T-start and T-end to sort of make it pretty on the UI. And for each of the tables within that configuration, so the configuration that we're looking at over here, each of the tables, I'm generating 3 tasks: extract, transform, load. And this is a very simple example of how you can sort of go about things in terms of creating your own dynamic DAG generator. Okay, so as you can see here, sorry, my laptop is doing things. As you can see here, I'm iterating through that tables array. I'm creating those 3 dummy tasks, essentially extract, transform, and load, establishing the relationship right here. And the last thing that I would want to do, like I was saying before, when the scheduler is scanning through your DAG files, it is looking for a DAG object in the global loop. And if we just create one DAG object, you'll only see one DAG out there. So what I'm just doing over here is I'm just so pushing all my DAG objects to that global scope so that it is visible to the scheduler to read it in, right? If I just scroll to my Airflow interface, all right. So these are the 3 DAGs that have been created by that. So if I just look at ETL pattern 1, if you remember, there were 5 tables that I was creating ETL for. So you know, so we've got the pattern over here. Similarly, if I look at, sorry, my laptop has slowed down significantly for whatever reason. Come on, check along. Okay, sorry, this took a bit of time to load up. But essentially, over here, I had 4 tables in my configuration, so that's what this is doing. Now, of course, you can go bonkers with this whole DAG generator and configuration concept. so one of the examples that I prepared, hopefully it loads up fine, because going by, maybe I just need to disable my other DAG, and that'll make things a tad bit stable. Anyways, so I've got this a very very complex sort of DAG generating logic over here. So for example, the config that I'm working with is follows a very complex structure itself. So what I'm trying to do here is I've got different extraction patterns. Again, the example that I was talking about, wherein I would want to extract multiple entities from multiple sources, and each of those entities might have an upstream dependency, like it might be waiting for an event to appear in an event bus. It might be waiting for a particular time trigger, and so on and so forth, right? So, so I've sort of just created this construct that works well with that sort of a use case, wherein I've just created, it's just a JSON construct with just key value pairs to sort of, let's say, for example, what is the source pattern configuration of, okay, I'm getting it from a database. For example, if I was trying to hook it up into Azure, I might want to trigger certain pipelines remotely as well. So yeah, again, these are very case specific. I can do things like this has an upstream dependency on another DAG task, which might sit in another DAG. So so you can do all of those things with it, as long as you can code. So, okay, I might have to just restart my Airflow instances, because my laptop is acting up a lot.
Whilst you're just restarting Airflow there, we have another question, which asks about what are some lightweight options for log aggregation and alerting for monitoring your Airflow instance?
So you can, so in terms of logging, it does have the capability of integrating with, so let's say if you're trying to use AWS, for example, you have the capability of hooking it up into CloudWatch. If you're using Azure, you have the capability of hooking it up to log analytics workspace as well. So all of the functionalities are just configurations that you do while setting up Airflow. So you can even forward your logs to something like a Splunk as well, and do alerting on that part. So all of these things are achievable.
Yeah, fantastic, thanks. I think we should also be able to provide some links afterwards we can put on the Meetup page for people to go and have a look at the Airflow website and some of the documentation, and you'll be able to drill into a lot more detail on some of these things as well.
Yep. Cool. And sorry about this. Didn't expect this to happen. Takes a few seconds to load up. Any other questions that we have in there?
I have two questions.
Yep.
Hi, this is Hussein. I've been using Airflow only for like 1 month. It's really good. But from my experience, one of the things that I struggled to know an answer for is, you know, in the task, the log, when you log inside the task, it doesn't get shipped with the Airflow logs itself. So if you ship the logs to S3, for example, or even the local files, I don't see the logs that I do in my task. Only when I use like print, it comes. But when I use the logging package from Python.
Oh, yeah. So when you do logging.info, yeah, I've faced that myself, because it's the behavior is pretty intermittent with that, because sometimes you'd see those logs and other times it somehow messes up with the Airflow's logging mechanism. Personally, I haven't been able to solve that problem because that is, from what I understand, that's really a bug within Airflow. So yeah, so I've been trying to stick with print statements myself, so that I can get meaningful output out of it. But yeah, I think that's just a bug with Airflow itself.
Okay, it's good to know that Brent is the solution then, because I did it and I didn't know if it's a good practice or not. So, and I have been googling about it, and yeah, without an like definitive answer, but that's good. Cool.
Yeah.
The second question is about debugging. If I want to run Airflow locally and debug the code, if there's a way I can do it.
So if I understand it correctly, so you want to run the Airflow locally, and so the way I'm doing it is the way I would assume that a developer's environment would be set up as well, wherein you can essentially have a Dockerized Airflow instance wherein you can sort of code in and do your local development. And then once you push your code to the remote repository, it goes through its paces in terms of CI cycle and does what it needs to do. Does that answer your question?
Yeah, I was mainly asking if I can debug in the IDE, but seems like it's
in terms of no, you cannot do code changes within the IDE itself. At least not out of the box. That's not a feature that Airflow comes with out of the box. So you cannot directly change the code from within the UI. I didn't mean the IDE.
Yeah, I guess point. Okay, it's fine. Thanks a lot.
Guys. All right. So the problem was I had triggered the workflow that I created. I had given it a very tight schedule, which it was running again and again and again. And I saw like 400 odd instances that was running continuously. So sorry about that.
That's right. This way we know it's actually a real demo and it's not just pre-recorded.
Yeah, sorry about that. I'll just disable this as well.
Meanwhile, can we ask another question?
Yeah, sure. Yeah, please.
Sure. Hi, Nishant. Just wanted to understand which IDE are you using? Like what you're sharing, is this Visual Studio?
I'm using, yeah, Visual Studio Code, yes.
Okay, and I haven't worked with Airflow before. So once you are done with your development, how exactly do we productionize it?
Mm-hmm. So essentially, like I was saying before, in terms of hosting Airflow itself, that needs a bit of a thought. In most cases, what I've seen is we containerize the Airflow components, especially your worker nodes, so that you can sort of scale out pretty nicely. So in terms of components that Airflow uses, so there are 5 main components that you'll have to deploy in production. So you've got the scheduler, you've got the worker nodes, you've got a Postgres or essentially a SQL database, which is essentially Airflow's metadata database. So all the all the task statuses that we were seeing, all of that is updated in the database, and the changes in the database are reflected in the UI as well. Consequently, you can also, the last component is a queue. So essentially, to get the scheduler to work with the worker nodes, what happens is the scheduler is essentially looking for new tasks to schedule, and it pushes the tasks instances into the queue. And the worker nodes are just getting the task from the queue and executing it and updating its status in the database. So all of these, and of course, you've got the web server component of it, which actually gives you that UI that we were looking at before it crashed. And so that obviously needs a lot of thought in terms of how you go about deploying it, depending on where you're deploying it. So if you're going with AWS or you're going with Azure, so that'll need a bit of a thought and the kind of workloads that you plan to run on it.
Right, and just to follow up on that, so is that where the concept of this managed airflow comes in? Like, for example, in GCP,
yes.
they call it data flow, where you have everything packaged in one place.
Correct. So you can also use it as a, so if you want to get started pretty quickly, then you can go, and if you're working in the GCP realm, again, depending on the cloud that you're using, then yeah, data flow is where you would go. In AWS, that is MWA, so it's managed. Sorry, I don't remember. Tim, do you remember the full form? I don't remember the full form at the top of my head. So it's called MWA. Then there's a vendor called Astronomer. They're pretty. They have a good reputation as far as Airflow is concerned. So they have. They also offer sort of managed Airflow solutions. So they offer it as a SaaS solution essentially.
Yeah, thank you.
Oh, finally, we got it working. So the snafu that I made was when I did the use case 0, I scheduled it and it was catching up from the start date. And I had like 500 instances running concurrently. And yeah, my MacBook wasn't coping well with that. Yeah, so I'll just motor through the rest of it. So essentially, the last use case, before I get into the last use case, the way I'm using that configuration file that I was looking at earlier and the DAG generator, this is the DAG that it is generating. So I've gotten to get it to work with the upstream relationships, any DAGs that, any upstream DAGs that it is dependent on. And if you have this sort of a pattern being followed for different jobs, you just need to keep adding configuration and it will keep generating DAGs for you within the Airflow interface. Now, the last bit, which is this use case. Now, this is a bit out of left field because more often than not, you're doing daily batches as far as ETL is concerned. Now, we came across a use case wherein the scheduling of these ETL jobs wasn't deterministic. Yeah, in the sense that the files could arrive at any time, and they had to be processed in near real time. And they already had an Airflow instance running. So what we tried implementing there was the event-driven DAGs concept. Now, if you remember, one of the flavors of operators that I was talking about earlier was called the sensor operator, right? Now, in using sensor operators, one of the sensor operators that are out there is called the SQS sensor operator. So in AWS, there's a service called simple queue service. Essentially, it's a message queue. And you can push in messages in there. For example, again, it could be a metadata about a file that has just landed in a particular S3 bucket location, for example, right? And then you can have this sensor operator, which is continuously listening to the queue for messages like these. It dequeues the message, reads that configure or the message information, processes that message and determines the downstream pattern that it has to trigger. And then it'll trigger another DAG, which will actually, process that file, for example. Consequently, it will also trigger another instance of itself so that there's always something listening to the queue, right? So this is another use case that I've personally come across that has come in really handy. In this case, and this is the last use case that we're going to go through, things will look a tad bit different from what we have seen so far. So again, we declare the DAG object like so. So you've got the queue reader. The only difference over here is I'm just triggering it once, because like I was saying, once it is triggered once, it will keep triggering itself so that there's something always listening to the queue. So as and when Airflow boots up, when it sees the once schedule interval, it will just trigger it. And then all the subsequent triggers will be taken care of by the DAG itself, right? Again, I've got the dummy operator for start. Now here I'm using an SQS sensor operator or SQS sensor. Again, the parameters that it accepts is available in the Airflow documentation as to how you can go about using it. But the main couple of parameters that it accepts is the queue URL that you're connecting with, and the credentials that you're going to use to connect with your AWS service. Now, as you can see here, it is looking for an AWS connection ID. Now, within Airflow, there's a concept of connections where you would essentially manage all of these secrets, like could be database credentials, could be credentials for AWS, could be any sort of secret information that you want to hold, and that can be used by any tasks across Airflow to utilize and connect with that external service, right? So that's another key concept that you should be aware of. So in this case, I'm using a AWS connection ID, which has the name AWS default, where I have the client ID and secret for the purposes of the demo. And then I'm just pulling in one message at a time for now. And I'm polling the queue every 4 seconds. Yeah. Now, then I've got a trigger DAG run operator. So something I was talking about while answering one of the questions. So this is to use to trigger another DAG. In this instance, I'm just triggering myself, right? After I've read the message, I want something to listen to the queue always. So I'll just trigger the same DAG. And then I have a Python operator, which essentially is processing the message and determining the pattern. So in this case, what I'm doing is I'm just passing the DAG name that I want to trigger in the queue message. And based on that, I'm then using that information in my next task, which is called the trigger DAG run operator. It's called, I'm using the trigger DAG operator task, which is again triggering another downstream DAG, which will actually do the file processing, for example. Now, one thing interesting you'll see here is this, which is using Jinja templating. So certain parameters, certain things within this construct, you can use Jinja templating, especially when you have to go from, for example, environment to environment, where let's say, you have to determine between dev environment, set environment, prod environment. You're holding that variable in a common space. any referencing it using Jinja templating, right? So it's dynamically sort of pushed in there. Now I'll touch on XCOM in a bit, what this actually does, which touches on one of the questions that were asked earlier: how do we get two nodes to talk to each other, right? So in practice, I have to, because our Airflow crashed, this DAG crashed. Now this is a perfect use case to essentially run this from the point of failure. So I just click on that task, click on clear, which will clear the statuses of this current task and all the downstream tasks and get it running again. Okay. So, and I'll do auto refresh on. Okay. Now I've got the task listening to my queue. I'll just click on this task and go to logs. And while this is loading up, I'll go to my SQS. Hopefully I'm still authenticated, but we'll find out. Sorry, something is happening in the background, which is really slowing down my laptop.
Perhaps just a question for the audience. I wonder, we're chewing through a little bit of time here, so I'm wondering if people would be interested in a follow-up presentation. If we're able to do something in the future, in a week or a couple of weeks or something, would people be interested in going into more depth with Airflow, and perhaps looking at more of these things like the XCOM and some of these other functionality, and perhaps going through some other use cases as well? If you're interested in that, put something in the chat and let us know, and we can try and bribe Nishant to come back, or we can do something to try and get some extra talks if this is a really good topic.
Okay, we're getting a bunch of yeses in there. That's good. So should I, just in the interest of time, should I skip through this particular part, or how do you want to?
If you want to sort of complete what you're doing with this this particular use case.
Oh yes.
But maybe we'll perhaps pause after that. And we'll try and wrap up this evening because people need to eat food and look after families and other things. So yeah, and then maybe it looks pretty positive. A lot of people would be interested in follow up. So we'll have a chat with the other organisers and see what we can do in the future. Yep,
no worries. Yeah, so just to wrap this up, essentially it pulls the message out of the DAG, out of the queue, and it is essentially triggering another DAG within Airflow, and it is triggering itself as well, so that we have something continuously listening to the queue. So essentially, this is a way you can, in a way, implement an event-driven tag as well. It doesn't have to be always scheduled. And in the cases where you do have to run these orchestrations near real time. So that pretty much brings us to the end of the 3 use cases I wanted to showcase. Sorry we couldn't get through a couple of concepts that I wanted to talk about in terms of XCOM and all that. We can pick that up in the next session. So yeah, that's pretty much it from me, Tim. All yours.
No problem. Thanks very much, Nishant. There's a couple of questions still in the chat, but we might take a copy of those and then we can try and respond to those on the Meetup page, and we can put some extra links and information there. There's one about the passwords, are they encrypted, and all that sort of stuff as well. So, so we'll try and address some of those on the Meetup page. And we'll quickly jump back over to here. And we'll quickly jump into the marketplace. So I know it's getting a little bit late, but we might jump into here quickly and see if anyone has anything they'd like to share. We'll give everybody 2 minutes, so we'll try and keep you on a timer. If you've got a job that you're looking for data engineers and people to help with, or if you're looking for a job or something, or if there's anything about specific data technologies, then feel free to unmute yourself and we'll give you 2 minutes to share with the community.
Hi, I don't mind if I jump into the front of the queue, do you?
Thanks, Terence. Go for it.
I just wanted to say hi to everybody. I work at Seek as a data scientist, and across our team, we're looking for data scientists and maybe ML engineers, maybe slightly different than data engineers, but various roles. And if anybody wants to talk to me, I'm very happy to talk about that. I have one posting, I might just put it in the chat. And I don't want to take up too much time because I know we've sort of run late. So if people have questions, I'm happy to talk. But other than that, that's it.
Thanks for that. What I'd also add is that you could also turn around and share some links on the Meetup page. You could add a comment in there and say, here's a position, and you can add a link to Seek or wherever the positions are advertised with some contact details, or you could put a phone number or something in there that people could call as well. Thanks. Is anyone else?
I might jump in as well.
Sure.
If you don't mind. I'm actually part of Seven as well as Nishant and team. And yeah, basically we're also looking for people. And because we are, I wouldn't say that we are just data and analytics consultancy, but it's a massive pillar for us. And we're kind of looking for very different profiles. Data engineering would be one of the major ones, but also happy to speak to any data scientists or data warehouse developers or basically anyone. And it's not like you have to actively looking for a job. We also happy to talk to people who are just want to learn more about us. I think you can also reach out to Tim and Nishant directly and see what's their experience like. But I might pop my LinkedIn page just there. So if you want to speak to me completely confidentially,
Sure.
just feel free to pin me a message.
Thanks for that. And again, you might want to put perhaps a link or some details on the Meetup page as well. I'll just warn people, if you ask me or Nishant, we're a little bit biased because we sort of work. Feel free to reach out. Hamid, would you like to share something?
Yeah, thanks, Jim. Great talk, Nishant. Thank you so much. And my part. So we have there's a Data Engineering Bytes conference, which is happening the week of October 5th. So 5th, 6th, and 7th, I guess. So I will add a link, and I'm also speaking at it. I'm talking about building reliable pipelines. It's more about shift left testing. So if you like that topic and all the other topics, they're like great, some other topics as well. I posted that link. Do register for it. It's free. Yeah, thanks.
Fantastic. That sounds exciting. And if Hamid's presenting, then you know that it's going to be good. There's going to be some good content in there. Do we have anyone else? You could raise your hand or unmute yourself and share. Okay, well, I think we sort of covered it off. So there was the details about that. Yeah, and post details and links, which is good. And I think some people have been posting the links in the chat there, which is awesome. So also thanks to ThoughtWorks. ThoughtWorks do provide the meetup links and sessions and stuff to make Data Engineering Melbourne happen, which is awesome. So thank you very much to ThoughtWorks for helping to support the group, and so that we can do these sorts of talks and presentations. So the next, this may change a little bit, but the next scheduled talk was on Thursday the 28th. And if you'd like to reach out to any of the organisers, Andrew Jones, Harmeet, or myself, our details are on the screen there. But stay tuned on the meetup page because I think we might try and do a follow-up. I think there's a lot more detail that we could go into and some other really cool things that Airflow can do that'd be really exciting to see. So when we can get something scheduled, we'll put an update on the meetup page and we'll send that out. Thank you all very much.
Thanks. Thanks, everyone.
Thank you, Tim. Thank you, everyone.
Thanks, Nishant, for presenting. Yeah, thank you.
Thank you, Amit.
Thanks, Tim.
No worries. Thanks, Amit. I'm sorry, we sort of, it was a really good topic. I was really enjoying it, but I'm also getting hungry. So